So one last video on mesh analysis, and I'm just going to quickly look at this example, which is on the fall 2018 midterm for CET236. So this question is a little tricky, and the trickiness comes about simply because of the dependent voltage source here. So this VS2 is a dependent voltage source, so it's got a diamond shape, and it depends on Vx, which is defined over here. Okay. The other tricky thing about this is that Vx has its positive and negative sides defined, as does the output voltage Vout, which is what we've been asked to find. Note also this question requests that you use mesh analysis. The aim of this question is to show that you know how to apply mesh analysis. So if you solve it using any other technique, that's okay for checking, but to get most of the marks on this question, you need to do it using mesh analysis. Okay, so let's apply the mesh analysis. Right, so here we go. Now, because I've got a positive sign here, I'm going to want my I1 to flow into that positive sign. I don't want to have to redefine the polarity around my R2 resistor. Similarly, so once I've got that defined, so that's my I1, that means I have a positive sign here, a negative sign here, a positive sign on this end of R3 and a negative sign on this end of R3. Then I can go up here and I've got a similar problem here. I already have the positive side of R5 defined for Vout. So I'm going to define I2 to go around that way. That way I don't have to play with the signs. So that if I2 goes that way, that means that's a positive, that's a negative, that's a positive, and that's a negative. Okay? So now let's try applying KVL for the I1 loop. Right, so KVL for I1, and that is pretty easy. So I'm going to start down here. It's got minus 10 volts plus VR1 plus VR2, which is Vx, plus VR3 equals 0. So now let's write that out in terms of the mesh currents. So that's going to be minus 10 plus 2800 I1 plus 3200 I1, right? 3200 times I1 R2, plus 5700 times I1 plus I2. And that equals 0. Okay, so now I can group like terms, and I get that's 2800 plus 3200 is 6000, plus 5700 is 11,700 I1, and plus 5700 I2 equals 10. Okay, so there's my KVL equation for the loop I1. So now let's go change color, and we'll look at the KVL for I2. And we're going around this way, so I'll start again down here with minus 10, minus 6 Vx, right, plus VR5, plus VR4, plus VR3 equals 0. So it's minus 10 minus 6 times Vx. Vx is 3200 I1. So that's 6 times 3200 I1. R5, VR5, which is also V out, is plus 4700 I2 plus 8100 I2, which is VR4, plus 5700 times I1 plus I2, which is VR3. And all of that equals 0. So then let's see if I can add this up. So this is 6 times 3000 is 18,000, 6 times 200 is 1200, so it's 19,200 I1, and plus 5700, so that's 25,500 I1. Plus, so I2 is 4700, it's 12,800, 17,800, 18,500. And that also is equal to 10, because we've got this guy over here that we have to bring over to this side. So that makes our matrix equation something like 11,700, 5,700, 25,500, 18,500 times I1, I2 equals 10, 10. And we should be able to put that into our calculators and solve for I1 and I2. However, we're still not quite there yet. What we need to do though is the question's asking us to find V out. To find V out, we need to say that V out is equal to 4700 times I2. So once we've solved for I2, we need to plug it in here to get our answer.